Hello everybody, in this video we are going to continue the conversation that we've had about finding the greatest common factor, but in this video specifically we're actually going to talk about how to factor by grouping. Now in order for us to be able to factor by grouping, we have to know how to find the greatest common factor of a polynomial. So with that being said, I'm just going to remind you of a couple things. When you're looking for the greatest common factor, you're looking for the biggest divider from your coefficients. You're looking if both coefficients have the same variable, then you want to find the smallest variable. And then if the leading coefficient is negative, then that lets us know that we need to also pull out and factor out a negative. So I'm just going to point out that because these two numbers were positive, then the GCF was also a positive number. If you look at the ones that are negative here, we have a negative 24 in the front, we have a negative 9 and a negative 50. Notice that their GCF was a negative number. So you find the GCF the same way, you just drag that negative as part of your GCF. Now from there, once we find our number, we're dividing the coefficients by that number, and then we're subtracting those exponents by that number, by that exponent. So with that being said, that was just a quick review. Let's go ahead and look at the problems on the back of the set of notes. So we're actually going to be doing a lot of factoring, but I feel like the introduction to factoring is factoring by grouping. So in order for us to factor by grouping, we have to have 4 terms. That means there should be 4 numbers in our polynomial. So if you look at your example here, this is a term, this is a term, this is a term, and so is this. Notice I have 1, 2, 3, 4. If you look at this example right here, 1, 2, 3, 4. I'm not just talking about the number, I'm talking about this whole little cluster here. That is considered a term. So there are 4 terms in this polynomial, so we are able to do factoring by grouping. So why is it important that we have 4 terms? Well, that's easy because your first step is to split it into 2 parts. The first half and the second half. So since you have 4 terms, I'm just going to draw a line right here. Notice that where I drew my line, here are my first terms, here are my last 2 terms. Make sure the sign belongs to the second half. So if I look at this one over here, I'm going to put a line right here to separate the first half. That negative belongs to the 15, just like that plus belongs to the 8. So when you draw this line or when you try to separate this, please keep in mind that these signs belong to those numbers. And if you leave it off, you're confusing a positive for a negative, and we don't want to do that. Okay? So that's step number 1. Split it. Split it into 2 parts. Now, I'm just drawing the line here, but you can do a whole box around it if you want to. But then what I'm going to ask you to do here is I want you to look at the first 2 terms, and I want you to find the GCF of the first 2 terms. Then I'm going to ask you to find the GCF of the last 2 terms. So let's start at the front with the first one. The numbers are 40 and 35. We need to find the biggest number that divides into 40 and 35. So this one is going to be 5. 5 divides into 40 and 5 divides into 35. Now you can also grab your calculator and check it if you want to make sure that 5 indeed is the biggest number here. Now I'll show you how to do, I showed you guys how to do this in a previous video, but if you need to, I'll go ahead and throw one in here in a little bit to remind you how to use your calculator to find the GCF. So with this being said, we know that 5 is the biggest number. So we're going to say 5, and we're just going to write it in here. Now notice that they both have k. So if they both have k, the smallest exponent is a 2. So our GCF is going to be 5k to the second power. Okay? All right, pause, put a pin in it for a second, and let's jump to the other side. I'm going to take whatever this sign is right here, and I'm going to put it right here. Okay, so this one is a negative. I'm going to drop down the negative. Okay, this is going to help us here in a little bit, and I'm going to tell you why it's really important. So because this is a positive, we're going to bring down the positive, and we're going to try to figure out what the greatest common factor here is, or divider. 8 and 7. So you can use your calculator, but notice that nothing other than 1 nothing divides into 8 and 7 other than 1. So if you need a quick reminder, I'll go ahead and show you. Go to menu. If you hit menu, you go to 2, you go to 5, and you type in 8, 7. And when these numbers don't have a greatest common divider and they tell you it's 1, that's still the number you need to write down. Okay, so it doesn't matter if it's a 5 or a big number like 10 or 8, you still have to use the 1. I highly encourage you write down the 1. Now notice that the 8 has a K but the 7 does not. So the greatest common factor of the last two numbers is just a 1. So now we need to divide and subtract. So I'm going to take this 5, K to the second, open up parentheses. Because even though it's the greatest common factor, we still need it to be part of our answer. 40 divided by 5 is 8. 3 minus 2 is K to the 1. All right, I'm going to do that again with the 35. 35 divided by 5, 7. 2 minus 2 is 0. I don't have to write it down. Take your plus 1. Yes, the plus 1. Open up parentheses. 8 divided by 1 is 8. Since we're not messing with the K's, bring it down. And remember, a K is the same thing as a K to the 1. All right, 7 divided by 1, positive 7. All right, this is how you know you did it correctly. You're going to look at both of the parentheses, and if they are exactly the same number, same variable, same exponent, same sign, then that tells you you have done it correctly. So I'm looking inside the first parentheses. I'm comparing it to the second parentheses. And once I see that they're exactly the same, I'm going to ask you to write it down once. 8K plus 7. Then I'm going to ask you to cross them both out. Just the parentheses. And you're going to see that there's two things left over. The GCF from the first one and the GCF from the second one are left over. So we're going to put that in its own separate parentheses. That and that came here. Now, I'm going to ask you to do this because I need you to get into the habit of doing this every time. Can we factor anything out of here? No. The only thing that will factor out is another 1. So that tells me it's in simplest form. If I look right here, I can only factor out a 1. So that tells me that both of these are in simplest form. So check and check. This is my final answer. Now, if I were to multiply this back, I should end up with the same thing. I should, if I did this correctly. So we're going to take a moment and we're going to speed things up a little bit. So we're going to do the second example over here. Notice we already split it. So I'm going to ask you to look at these two numbers and these two numbers. So the only thing that divides into 3 and 2 is a positive 1. So I'm just going to put 1. You can put a plus if you want to. But they do have m's in common. So the smallest exponent of the m's is m to the second power. All right, see this minus here? I'm going to bring it down. And then I'm going to ask myself, what divides into 15 that will also divide into 10? And the answer is 5. But that's it. Just the 5. Because even though the 15 has an m, the 10 does not. So in this case, these are my two GCFs. So we're going to say 1m squared parentheses. Let's divide. 3 divided by 1 is 3. 3 minus 2 is 1. 2 divided by 1 is 2. 2 minus 2, 0. All right, bring down not just the 5, but the negative 5. Open parentheses. Negative 15 divided by negative 5 is a positive 3. Bring down the m. Negative 10 divided by negative 5 is a positive 2. Pause and look. Pause and look inside both of your parentheses to see if they're exactly the same. And we can see that they are. So because these are exactly the same, we're going to say 3m plus 2. Close it. Cross it out. And then look to see what's left over. That's left over. That's left over. So that goes in the second parentheses. 1m squared minus 5. Now I do want to point out that order doesn't matter. If you put this parentheses first and then this one second, it's still the same thing. Because if you multiply 2 times 3, it gives you 6. If you multiply 3 times 2, it still gives you 6. So multiplication is one of those things that you can reverse the order and still get the same answer. So the order of your parentheses does not matter, but what's inside does. Now I can see that 3 and 2, there's nothing that divides into it. I can see that nothing divides into 1 and 5. So in this case, there's nothing to clean out. There's nothing to factor out. They're both in simplest terms. We are done. That's it. That's factoring by grouping. So we're going to take a moment to pause right here. And we're going to look at the last two examples, which will require us to pull something out. So I'll show you how to do that and how your answer should look at the end. So I hope these two examples have helped, and then I'll see you guys in the next video.